Welcome back, everybody, to AI for Civil Engineering channel, and also welcome back to our AI automation for construction materials takeoff series. So, if you saw part one, and this was part one of our video previously, we built a system that could take a single PDF sheet, send it through OCR, and pull out a list of materials. It worked, but it was slow, and every sheet had to be processed one at a time. And we used the API from OCR.space, and that was free tier based API that you had to convert each page of PDF into JPEGs and feed one at a time all the JPEGs to your Telegram trigger, and each sheet would be downloaded and analyzed with OCR, sent to OpenAI Assistant, and you'll get the list back. So now this is the updated, there's a massive update to this, and you don't need to convert any page, any sheet to JPEG, and you can just feed the whole PDF file, everything that in that PDF file, the whole sheets. So it's just one click of at a time. So this is a pre-processed structural engineering drawings. So the whole PDF needs to be pre-processed. I'll show it to you towards the video, end of the video, how to make this preprocessor. And once you did that pre-processing, then feed it the same Telegram node, and then I also built a JSON decoder. So this is a package that I found online from, I guess it's a public agency. It's in Arkansas. It's a bridge engineering package. The whole package, it has like 68 sheets, and this is index of sheets, and these are the titles. So it's a very information heavy package, and I wanted to find like a very complicated one, but this is complicated enough for the first pilot project. Let me go scroll down to the structural part. And this, you can see a lot of heavy stuff in the structural part, and you can see a lot of geometry, a lot of materials, a lot of information. So we're going to feed this into our AI, and that will be, so let me double check. I already sent it here, so I will forward it again to our Blueprint AI. So this is our Blueprint AI, and I'll send it again, and I'm testing this workflow. So here it goes. Everything gets into all these different nodes. It gets processed by all these nodes. This is an OpenAI node. It takes a little bit of time to process the whole information. It goes to these codes nodes. I have two code nodes, and you can see here the list of all these. It gets messaged back to you. And this is also a database, which is the Google Sheet. So you can see it in Google Sheet as well, the whole list. You can see every single one of them are a bid item, like guardrail terminal type 2, guardrail type B, like wire rope, sandbag ditch checks, so sediment basin and rock ditch checks, and filter stock. So these are all very important information, and joint sealer type 3 or 4. So construction joint, lateral slide, and bridge jacking. So there is some human intervention is also necessary to check all these items one by one and see if it misses something. So I'll talk later about that missing aspect of it, like how to control the missing part and how to do the prompting in the OpenAI node. So I'll show it to you later. So if you followed the video so far, then please like, share, and subscribe to this channel. And we have a lot of cool content based on your preference. And this video is also based on the interest in a lot of comments and emails that I received from the part one. So I made this video, and this is a massive update. Welcome back to the detailed development of this automation tool for construction material takeoff automation. So first of all, before we can process an entire PDF of structural drawings, we need to give Google Colab the right tools for the job. So this first block of code sets up the OCR environment, which is the optical character recognition. And we are using the completely free library of OCRs, the PyTesseract here. And these libraries completely free for unlimited number of sheets that you have in the PDF. So it's pretty budget friendly. And we started updating the system and installing Tesseract, the open source OCR engine that will read the text from scanned drawings. So if the drawings are scanned or the drawings are recognizable, so it doesn't matter, the OCR will pick it up. And then we installed 3 key Python libraries, which is the PyMu PDF, this library for opening and navigating through PDFs, and PyTesseract for running the OCR. So this is the PyTesseract library that we want to install, and Pillow for handling images. So Pillow is another library that we want to install. So that's basically our environment. Finally, we point PyTesseract to the location of the Tesseract binary, so everything works smoothly. Once the environment ready message, so we have like an environment ready message like this. So there's a tick mark as well. So this basically gives us the go or notice to proceed. Okay, this block of code works. Go ahead and continue for the next block. And we know Colab is fully equipped to start extracting text from our multi-page PDF. So this message tells us that. All right. With our environment ready, the above block, we ran it and it's ready. So now is the time for the second block in this code. The next step is to get our PDF into Colab so we can process it. In this block, we will upload the structural drawings set directly from our computer into the Colab session. Once uploaded, Colab will store the file temporarily so our script can read it page by page. And you can see here the name of the file that I found online, and that's from one of the public DOTs. The file is public online and it has 68 sheets inside the PDF, all very information heavy document. So we just uploaded that. So when you say that choose files, so it uploads from your computer. From there, our custom functions will use PyMu PDF. So PyMu PDF was one of the libraries that we installed before, and it will use that to open the PDF, check each page for an existing text layer, and only trigger PyTesseract OCR if the page is actually scanned. If the page is not scanned and it's recognizable, then it might not. It will not use PyTesseract OCR. This hybrid approach makes it fast, accurate, and avoids wasting processing time on pages that already contain selectable text. So yeah, we don't want to waste the processing time by just doing OCR on every page. If it's recognizable, then that's actually much better. When it's done, the output won't be split by page. Instead, it will merge everything into one clean block of text, ready for the next stage of our AI automation to identify every single construction material inside the entire document. All right, we ran the environment, so the environment is ready. Now we are trying to upload the document once again, just for you to see it. So that's the document PDF. Oops, no, that's the JSON. So I have to bring the PDF. PDF, it will take a while. So here, so that's a PDF plan. It's surprisingly pretty fast, as all 68 pages are here. Okay, so saving 2020 AR, the Hiroshi Creek final revised plans. So okay, so now our environment, Google Colab environment, does have our document to read it. So imagine you're like hundreds of pages of PDF. You just upload it like this to be analyzed. All right, so the next section. All right, now let's move on to the next section of the code. And these are basically introduction to these functions. Now we are moving on to the core engine of our automation. So these functions are where the actual text extraction happens. So the first one is here, and turning a PDF full of structural drawings into one clean block of text that AI can understand. So basically we are talking the AI or LLM language in this section. All right, explaining this function extract page text with OCR fallback. Think of it as a smart decision maker for every single page. Here's what it does. Step 1. it asks PyMu PDF, which the library that I provided before, we installed it, if the page already has a selectable text layer. So that's basically making sure if it is a recognizable text or it's a scanned, whether or not to use OCR. So that's basically the function here. Many PDFs generated from CAD or design software contain text we can copy directly. And if that's the case, we can skip OCR entirely, saving time and keeping accuracy very high. Step 2, if the page is blank or scanned as an image, we don't give up. Instead, we render that page into an image at a clear resolution and send it to Tesseract, which is PyTesseract, that Python library that we installed before, our OCR engine. Tesseract then reads the character line by line. So this is that condition. So if text and if OCR. So if there is an OCR, then it reads it line by line, and we even calculate an average confidence score based on word level detection. So this is that confidence score. So what is the percentage of confidence that it extracted the correct word or the correct text? That means we don't just grab the text, we also know how reliable the extraction was. Moving on to this next function, which is called PDF to JSON single text. So this function basically, it grabs all these 68 pages or sheets of that drawings, collect all the text from them, and make it like a big giant text warehouse or a text dump file. So that is this function. So this one acts like a master controller for the entire PDF. It loops through every page, and for each page, it either grabs the native text or fall back onto the OCR function we just defined. So that's what this one does. As it moves along, it collects all the text parts and merges them into a single string. So it's a giant single string. The result is wrapped into a clean JSON object with metadata. So JSON is very important because we could have done it in Notepad, but here we need to make sure that that's the JSON and that's readable by N8N. N8N is our automation tool, so we're making sure that the output is a JSON file. So this is PDF to JSON. So that's basically the intention. Okay, including language, whether OCR was used, how long the processing took, and DPI we rendered that. So those are all like some functions that you can also, the parameters that you can tweak. So those are the DPIs, the page to integer, and then page from integer is 1, integer is -1. So this bool equal to true. So these are the things that you can play around with a little bit. So I put the DPI for 250 for now, so you can increase this number to 300 or decrease it to 200. So it depends on your timing and processing if you care about. And this is exactly the kind of a structured output. As I mentioned before, the JSON is actually the kind of structured output that we need for AI automation. One field that holds the entire text and supporting metadata that gives us insight into the extraction process. So that's this last line, and we print everything. So let's run this. So this thing, I guess it's already ran, and it says converter ready. Use PDF to JSON, PDF file name to run. So file name is already uploaded there. So compared to the part 1 video that we did like a month or 2 months ago, so where we had to process one sheet image at a time, this approach is a massive leap forward. With these functions, these 2-3 functions that I just talked about, we can feed in an entire 68-page structural drawing set, or you could do like hundreds of other pages, everything for free, no limitations. Extract all the text in one pass and pass it directly to our AI-powered takeoff system. It's efficient, it's scalable, and reliable, which is exactly what construction automation needs. So here you go, that the converter is ready. Let's go run this part, the PDF to JSON single text. So I believe that is ran too. So here is a 68 page, so it prints everything in here. So that's our giant text. In here, it says like, do you want to allow downloads? So Colab, okay, allow it. So here we go. It gets created, and this is one big giant JSON file. All the text extracted from those 68 pages into one file. So it also goes sideways. So it's a giant text file that AI can read it. Now we can clean this. So this was the preprocessor. Now we can clean it. So that JSON file that we created from the Google Colab, we can feed it here into this Telegram app. And you can use not only Telegram, whatever trigger application you're using. You can use a webhook, you can use a Google Drive, you can use anything else. So here it's pretty, I already set it up. I created like a bot here in Telegram, so it was everything ready. So you can use whatever you feel comfortable with. So that JSON file, we feed it here, and then it gets all those bit items get cleaned up by OpenAI, and it formatted in a list format, and only the material itself in an item format. It can report in two places, which is one, the Google Sheets and Telegram. So every node, like let's go over every node. So originally we went through this pre-process, that Google Colab was this pre-process part. Now we're going to the engineering text dump. So here is the first trigger node. As you can see here, we don't change much. So how to set up this trigger and how to create these AI bots inside the Telegram, which is the Blueprint AI that I made it last time. You can watch the part 1 video. And then the trigger is based it should trigger it based on messaging. So as soon as you're sending a message or uploading a file, then it gets triggered and it goes there. If you have some problems with how to connect your Telegram application into the N8N, just use the documentation. There are a ton of information over there. So that's pretty simple. And in the settings, so you don't change much. This display node and flow is turned off. And you can go to the second download file or get file node, and that's also a Telegram node. So whatever you fit into the Telegram application here, that's the JSON format, and also you can see it in the table format or in the schema format. Then you download that file, whatever that JSON that you fit, you need to download it. So here is that download, and make sure that this button is on. And here the output should look like this. That's file 30.json. Those are the extension. They have the size, file size. Okay, the file is now on N8N. After that, this is the JSON decoder. So this code node takes the JSON file that you got it from the Telegram, and it basically decodes it from base64 into the normal text. And then parses it into the JavaScript or JS object. Finally, it keeps only the important parts like text, metadata, and file name, and output them so the next node, like OpenAI, can use them directly. So it's basically like a little pre-processing inside the N8N to make it one layer more cleaner for the brain of our automation. So here, this node. So let's open this node, and you can see here this code that you can copy it. It's a pretty short little code. It's just like a cleaning or decoding your previous file that it got it. So it changes the file format and from base64 to the readable text, the UTF-8. So they're parsing it, and this will be the output. The output looks like this, and it's all text. Okay, so those text, you can feed it to the OpenAI. All right, in the OpenAI node, so you're using your account, the setup of your account. You can use the documentation or my previous videos, how to set it up. And you have your APIs, right, already connected. And resources text and message a model. And the GPT-4o Mini is very cheap, and it's very effective. So you can use this as always. So there are a lot of other models that you can use, but those are getting pretty expensive pretty soon. So this 40 Mini, it's pretty good, it's fast, and it does the job. So the prompting is a little bit tricky in part one. So we didn't change much compared to the part one, but here you can go ahead and see the prompting once again. And this JSON.text, we can just input it from the previous node or that JSON decoder. So you basically grab, like, let's say, go to the JSON and you have the JSON.text. So you can bring it basically here, drag and drop it. So once you did that, then the next portion is user or role. Okay, let me scroll a little bit here so you can see the whole. You can stop and pause the video and see how the prompt is written. This is very important, like, you know, exactly what you want for this. So what should be your output? It's a little bit difficult to do the structured output from the OpenAI, but that's why I have like that other JSON code in the next node to clean it up and format it. And these are the examples. You give them a lot of examples, how you want all these bit items. So you give them a caution, boundaries. You give them a lot of these boundaries and conditions. So you get all your output in a structured way. So here is simplify output content as a JSON. And here, earlier in the meeting, earlier in the video, I mentioned about how to control the output of this, the accuracy. So if the accuracy is lower, like closer to 0, and the temperature, so that it's more deterministic value or output. But if you increase this closer to 1, this temperature, then OpenAI or LLM has a lot of permission to be creative and add more language to it, or sometimes like it causes inaccuracy that probably a bit item that is not even there, and they will list it for you just based on the guessing. So the temperature, to keep it low, that's very important. So keep it at 0.2, 20% is okay for the cleaning. So in the setting tab, we don't have much. So this is basically the output of your OpenAI node. So after that, you go to this formatting code. So the formatting here, sometimes here the OpenAI gives you with a different header. So that header is not consistent. So make sure that in case you didn't get a good answer or everything kind of fails, it stops. So this might be one of the reasons. Like for example, here the output is construction materials. Sometimes they don't have this underscore. Sometimes like they don't have like the capital lowercase m or c. So those are some of the things that you can hash out and be careful. So this is pretty simple. That is the return, and you're formatting everything into the rows. So okay, after that you send it to the Google Sheets for your database or for your Excel sheet, whatever you're trying to store all these bit items. So this is construction materials, wire rope. So there's a 3, 4, 5. Okay, and finally, and this was the one that you saw all these coming into the Telegram. Here is your Telegram.